Ever tried boiling water for your tea and wondered why it's taking longer than usual? Maybe you're not at sea level. You see, we've all been taught this neat little fact in school. Water boils at 100 degrees Celsius. But let's throw a dash of reality into that hot pot of misconception. Imagine this. You're on a hiking trip, nestled high up in the mountains. It's chilly. You're hankering for a hot cup of tea. You set your pot on the stove, crank up the heat, and wait, and wait, and wait. But the water's not boiling. You might be thinking, is my stove broken? Have I offended the tea gods? No, my friends, you're a victim of the 100 degrees Celsius myth. The truth is, water's boiling point changes with altitude. Up there in the mountains, water boils at a lower temperature. So next time you're on a mountaintop trying to make a cuppa, remember, it's not your stove's fault. Now you might be scratching your head and asking, why on earth does water not always boil at 100 degrees Celsius? Well, let's unravel this intriguing mystery together, shall we? The boiling point of water, or any liquid for that matter, isn't a fixed number that's universally applicable. It's more like a temperamental artist that changes based on the mood of its surroundings. The two key factors that influence the boiling point are air pressure and altitude. Let's start with air pressure. Imagine you're a molecule of water in a pot. You're chilling at the bottom, just minding your business, when all of a sudden you start feeling hot under the collar, literally. You want to escape, to evaporate, to become a gas. But there's a problem. You're under this immense pressure from all the air molecules above you. It's like trying to push off a heavy weight to jump up. The heavier the weight, the harder it is for you to jump. Similarly, the higher the air pressure, the harder it is for you to boil. Now, let's talk about altitude. The higher you go, the less air pressure there is. So, if you're a water molecule sitting in a pot on top of Mount Everest, you're like, hey, this is easy. I can boil at a much lower temperature here. So, the boiling point of water decreases with increasing altitude. To give you an idea, at sea level, where the air pressure is highest, water boils at 100 degrees Celsius. But if you were to boil a pot of water in the city of La Paz, Bolivia, which sits at an altitude of about 3,600 meters above sea level, water would start boiling at around 88 degrees Celsius. That's a whole 12 degrees lower. So the next time you're making a cuppa and it seems to take forever to boil, remember this. It's not the water being difficult, it's just physics doing its thing, and you know what they say, you can't argue with physics. So it's not your water being stubborn, it's just physics doing its thing. So let's debunk that boiling myth once and for all. We've all been there, sitting in our science class, absorbing the fact that water boils at exactly 100 degrees Celsius. But as we've seen, there's more to this story than meets the eye. Firstly, the boiling point of water isn't a fixed value, it's a fickle friend, changing with the atmospheric pressure. At sea level, where pressure is highest, water boils at around 100 degrees Celsius. But if you were to boil a pot of water atop Mount Everest, it would bubble away merrily at just about 70 degrees Celsius. That's because the atmospheric pressure is much lower up there. Then we've got the matter of impurities. If you're boiling tap water, it's not pure H2O. Minerals and other impurities in the water can increase the boiling point. That's why professional chefs often add a pinch of salt to their pasta water. It's not just for the taste, but also to raise the boiling point and cook the pasta more effectively. And let's not forget about superheating. Super what, you ask? Well, water in a smooth container can actually be heated beyond its boiling point without forming bubbles. This is a potentially dangerous phenomenon, as any slight disturbance can cause the water to boil violently and potentially cause harm. So why does this matter? Well, understanding these quirks of water can help us in various ways. For instance, knowing that water boils at a lower temperature at higher altitudes can save mountaineers from undercooking their food. And being aware of superheating can prevent accidents in the kitchen. And there you have it, folks. The next time someone tells you water boils at 100 degrees Celsius, you can kindly correct them with your newfound knowledge. Just remember not to do it while they're holding a hot kettle.